Hello everyone. In the previous class, we discussed what? The nomenclature of cyclic organic compounds. Okay. So this one we discussed lastly. So in this compound, what we discussed here, 3 carbon atoms in the chain and 5 carbon atoms in the ring. But what is taken as parent here in the ring? Double bond is there here. Double bond is there, and it is what chain, side chain with the alcohol functional group here. So it should be now parent. It should be parent, and it should be what now here? Substituent. Okay, that's why what we have taken here, name, parent name. Parent name is what now here? Propan 1-ol. Propan 1-ol. And what is the substituent here? Cyclopent 3N 1-yle. Cyclopent, third carbon. Here first carbon, second carbon, third carbon, En. And first carbon has yle. Okay, so free substituent means free bond. The substituted substituent is called complex substituent we discussed. Now next case is here. In this case now here, so how many cyclohexyl rings are there? 2 cyclohexyl rings. Between 2 cyclohexyl rings, any carbon is there here? So there is no carbon here. No carbon chain. So no carbon chain between 2 cyclohexyl rings here. That's why here, out of 2 cyclohexyl rings, one ring should be taken as parent, the other ring should be taken as substituent. Okay, one is parent. Suppose I'm taking this one as parent. Suppose it is one of here parent compound. So this parent compound has how many carbon atoms in the ring? 6. So it is what cyclohexane is parent. And what is substituent now? The other ring is what now here? Substituent. What is the substituent here? Cyclohexyl. Cyclohexane. So one ring is taken as what? Substituent, cyclohexyl substituent, and the other ring is taken as parent compound. So what is the name of this compound? Cyclohexyl, cyclohexane. Suppose if you take the structure like this here. So here cyclohexyl ring, bond. Here it is like this, suppose. It is like this. Now tell me what is the name of this? Between this cyclohexyl and this cyclohexyl, how many carbon chain is there? 1 carbon chain. So this 1 carbon is there here. So between these two, what is there? 1 carbon. 1 carbon chain means what now here? It is methane. Parent is what now here? Methane. So parent should be methane. Between 2 rings, if the carbon chain is there, that carbon chain only acts as what? Parent compound. So this carbon chain with 1 carbon is parent, methane. And how many cyclohexyls? 2. So here what we say now here? By cyclohexyl or di we can say. So dicyclohexyl methane. Dicyclohexyl methane. Now hexyl rings, both the rings will act as what now here? Substituents. And the chain between carbon chain between 2 rings will act as what? Parent. So methane is parent here. Dicyclohexyl means 2 substituents here. But here in this example, between the 2 rings there is no carbon. Directly linked both. Both the rings are linked with each other directly without any carbon chain between. That's why here one ring is taken as parent, one ring is taken as what? Substituent. So the name is what? Cyclohexyl. Cyclohexane. Next, in this compound, here how many carbon atoms in the ring? 1, 2, 3, 4, 5, 6 carbon ring. 6 carbon ring indicates what now? Cyclohex. And between all carbons in the ring, single bonds only there. So cyclohexane. What is the parent compound here? Cyclohexane. In this cyclohexane, numbering if you give 1, 2, 3, 4, 5, 6 carbons. Now here first carbon has 1 hexyl ring. Hexyl branch. The ring has what? Hexyl branch at first carbon, hexyl branch at third carbon, hexyl branch at fifth carbon. The same substituents on the ring repeated how many times? 3 times. When the same substituent groups are repeated 3 times in the ring, we have to use what now? Tris. Tris indicates what? 3 times. Here where they are located, first carbon, third carbon, and fifth carbon. So we say 1, 3, 5. Tris, hexyl, tris, hexyl. When we say bis, tris, tetrakis, we have to say the group name, the branch name within bracket. We have to write. So 1, 3, 5. Tris, hexyl, cyclohexane. A tris indicates what now? This one. So bis indicates how many times? Bis indicates 2 times. If same group is repeated 2 times, we use what? Bis. If 3 times it is repeated, it is called 3 times it is called tris, and 4 times it is called tetrakis. Tetrakis means what? How many times? 4 times. Pentakis means what here? Pentakis means 5 times. Like this, these special numerical prefixes must be used here. Special numerical prefixes like bis, tris, tetrakis, pentakis should be used here. So 1, 3, 5, tris, hexyl, cyclohexane is the IUPAC name of this compound. So next example. In this now ring has how many carbon atoms? 1, 2, 3, 4. Okay, the closed chain compound is having 4 carbon atoms here, and the branch side chain is having how many carbon atoms? 1, 2, 3, 4, 5. So 5 carbon atoms in the side chain and only 4 carbon atoms in the ring. Now which is parent here? This is parent compound. The parent compound is having how many carbon atoms? 5. That's what is parent name here? Pentane. 5 carbon atoms with a single bond between carbon atoms. So it is what? Pentane. In this pentane, at first carbon, it is first carbon, it is second carbon, it is third carbon, fourth carbon, fifth carbon. On first carbon, what is there here? Cyclobutyl. Cyclobutyl group is attached. So 1 cyclobutyl pentane is the IUPAC name. Why this side chain is taken as parent here? Because there are more number of carbon atoms in the side chain than what? The ring. Let's take the screenshot of this one. Now next one here. So in this now ring is made up of how many carbon atoms? 6. Cyclohex. And at least one double bond is there here. So it is called ene. Cyclohexene. Cyclohexene we have to say. Anyhow, wherever double bond is there, that carbon will be given number 1 carbon else. So the 6 carbons will give numbering. Anyhow, numbering doesn't require here, because only double bond is there now. So we say simply ene. 1 ene we need not to say. Cyclohex 1 ene need not to say. Okay. So next, cyclopentine. 5 carbon atoms in the ring, and it is having triple bond here. So it is called cyclopentine. Suppose if you give first carbon here, it should be second carbon, it should be third, like this, 4, 5. So it is a cyclopentine. And next one, what? Cyclobutene. Anywhere you can give number 1. Number 1 carbon should be having what? Double bond. So 2, 3, 4 carbon atoms. So cyclobutene, cyclopentine, and cyclohexene. So this they are what now examples here. In cycloalkene, it is an example of what now? Cycloalkene. And this is what example of what now? Cycloalkyne. Cycloalkyne. Take the screenshot of this now. Yeah. So now next one example here. Yeah. Now in this case, see this ring contains how many carbon atoms totally? 6 carbon atoms. So it is cyclohex. What is this? Cyclohex. 6 carbon atoms in the ring form. Okay. So cyclohex. Then numbering, how to give here? See here, this methyl branch is there. At third carbon, what is the methyl branch is there? Now we have to give lower possible number to what now? double bond. So here, if you start number 1 here, first carbon, second carbon, third carbon, 3 methyl is coming here. So 3 methyl cyclohexene, 3 methyl cyclohexene. Suppose you take number 1 here, number 2 here. Here also first carbon is given double bond. Suppose first carbon, second carbon, and third carbon, fourth carbon, fifth carbon, sixth carbon will come. Now 6 methyl coming now here. 6 methyl is preferable or 3 methyl is preferable? 3 methyl is preferable. So lowest possible number should be given to substituent. After giving lowest number to double bond, the methyl substituent also must be getting what? Lower possible number. That's why we have to take what now here numbering in anti-clockwise or clockwise. We should give numbering in anti-clockwise direction. We should not give clockwise direction like this. So this numbering is wrong. So whatever is printed there, that is correct numbering. So first carbon, second carbon, third carbon. So 3 methyl cyclohexene. Is that clear now? Next. Now in this example, here triple bond is there. Triple bond and one methyl substituent is there here. So the methyl substituent is attached to which carbon? This carbon here. Now while giving numbering, multiple bond and alkyl substituent, between these two, which should be preferred? The multiple bond should be given lowest possible number. That's a first carbon, second carbon, third carbon. If you give numbering here, first carbon, suppose first carbon triple bond, suppose second carbon, third carbon, fourth coming here, 4 methyl is coming. But if you give numbering 1 here, 1, 2, 3 methyl is coming. So like this, what we have to take now here, 3 methyl is preferable over 4 methyl. 3 methyl is preferable over 4 methyl. Is that clear now? So like this here now, 3 methyl cyclobutadiene. 3 methyl cyclobutadiene we have taken. 3 methyl cyclobutadiene is what now here, arithmetic name of this compound. Is that clear now? Next. So next example, if you check here, 5 carbon ring it is. 5 carbon ring. So here at this carbon, what is attached? Ethyl substituent is attached. Ethyl group is attached here. Okay. And now while giving numbering, we have to give lower number to what? This double bond. So if you give number 1 here, second carbon, third carbon, ethyl coming. If you start numbering here, suppose first carbon, second carbon, third carbon, fourth carbon, 5 ethyl is coming. So 3 ethyl should be there. That's why 3 ethyl cyclopentene. Cyclopentene. So these are what now cycloalkenes and cycloalkynes. Okay. Next, another example is checked here. So in this example, a OH group is attached to this carbon. OH group is attached. Wherever the functional group is attached, that carbon should be taken what? First carbon. Anyhow. So it is what now here, wherever OH group is attached, that only will be 1. If OH group is here, it will be 1 carbon. If OH is here, it will be first carbon like this. So anyhow, OH group should be given first position to that carbon. That's why need not to say 1 ol. Need not to write 1 ol. Simply we can write ol. So cyclopentane and ol, pentanol. Here A and an indicates what? Single bond between all carbon atoms. Ol indicates what? The secondary suffix of principal functional group here. Here only OH group is there now here. That's why that OH group only itself acts as what? It itself acts as what? Principal functional group. For principal functional group, which name we have to use? Secondary suffix name. Okay, like that. Next, in this example, here amine group is attached. Amine functional group is attached to this carbon. Now, this carbon should be given first position. First carbon, second, third, fourth. Okay. So now here we need not to say 1 amine, because wherever NH2 is attached, that carbon only is given what? First position. So need not to say 1 amine. So simply we say amine. What is a cyclobutane amine? Here E should not be there. Why E should not be there? E should be dropped here. Why? Because in amine, A is what now? Oval. In amine, secondary suffix name. The first letter A is what? Oval. When first letter is oval in the secondary suffix, we should not write E. So simply we say cyclobutane amine. Butanamine. We have to say E should not be written. Next, in this example, here 6 carbon cycloalkane is there. Okay. Now here this carbon is having double bond with what? Double bond with oxygen. C double bond O is what now? Ketone functional group. Ketone functional group. For the secondary suffix name is what? ONE, own, ketone. Okay, so this carbon will be given first position, second, third, fourth, fifth, sixth. Like this numbering anyhow. One O need not to write. Wherever C double bond O is there, that carbon only is given what? First position. So need not write one O. So what we say? Cyclohexane. Cyclohexane O. Cyclohexane O is IUPAC name of this compound. Is that clear, ma? Let's take the screenshot of this. Now, so next one, in our material it is given wrongly this name. Okay, so now check it here. Suppose here it is C double bond O. Here C bond COOH, C bond COOH, and C double bond O is there, right? Now in this case, now which carbon? This carbon should not be given number 1. Okay, so no numbering, no numbering to this carbon. To carbon. So to COOH carbon, numbering should not be allotted here. Numbering should not be given for the COOH. No numbering to carbon atom of COOH here for this group. Now this carbon to which COOH is attached, remember. To this carbon of the ring, COOH is attached. That point keep in mind. So it is what now here carboxy group. What is carboxy group? Now this carbon of CO ketone group, the carbon of ketone group is in the ring now, within the ring now. The carbon atom of C double bond O is forming ring here. And the carbon atom of COOH is not forming the ring now. The carbon atom of COOH is not forming any ring. That's why this carbon is not given any numbering. But this carbon is in the ring. That's why it is what now first carbon. And it is second carbon now. The second carbon, to second carbon, what is attached here? Carboxy group is attached. 2 carboxy is there. Now it is third carbon, fourth, fifth, sixth carbon. So at first carbon, what is there? Ketone is there. Now what is principal group in this case now? Ketone only principal group, remember, because this ketone is forming what now? The ring. The carbon of ketone group is forming the ring. That's why it should be taken as what now? Principal functional group now. Now COOH is not principal in this case. And we cannot say that COOH is less prior group than CO. Actually, in between these two groups, what is more priority group, more senior group is COOH only, okay. But here, COOH is not forming the ring. That's why the COOH is taken as substituent here. It will be taken as second grade functional group. Second grade functional group here. That's why we have to use which name? Carboxy. We have to use here. So 2 carboxy, cyclohexane one. Cyclohexane one. One is what? Secondary suffix of principal functional group here. For CO ketone group, the secondary suffix name is one. Cyclohexanone. So 2 carboxy, cyclohexanone, we have to take this one. But suppose if we take the structure like this, cyclohexane with COOH. In this case now, no other group is there now. No ketone group is present in the ring. In this case, this carbon only is given first position. And when COOH group is carbon containing group is attached to cyclic compound, what we have to say name here? Here first carbon. Let's see. Okay, so first carbon, second carbon, third, fourth, fifth, sixth. Okay. Now in this case now here, wherever the COOH is attached, carbon containing functional group is attached. In this case now, for COOH, which name we have to use now? Carboxylic acid name we have to use. Special secondary suffix name should be used here. As ketone is forming the ring, we have given ONE to ketone, carboxy to this COOH. But here only COOH is attached to cyclohexane. Now what is the name of this? Tell me. Cyclohexane carboxylic acid. Cyclohexane carboxylic acid. And I told you one more example like this. Cyclohexane with CHO. This CHO will not be given numbering, but this carbon will be given number 1 position. Now it is what now cyclohexane, carbaldehyde we have to say. What we have to say? Carbaldehyde, cyclohexane, carbaldehyde we have to say. We should not say al, formyl, al should not be used here. We should use only carbaldehyde. Carbon containing group attached to the cyclic compound will be given special secondary suffix. Is that clear? So in this case, it is cyclohexane carboxylic acid. But in this case, it is not carboxylic acid derivative. It is a derivative of what? Cyclohexanone. Cyclohexanone is parent. Cyclohexanone is parent. And carboxy group acts as substituent. Second grade functional group is nothing but substituent. So this point we should not confuse. Okay. Next. Now in this case, now ring contains how many carbon atoms? 6 carbon atoms. Here, one of the carbons is what now? Ketone. One of the carbon atoms is ketone. So it is within the ring here. This carbon of ketone is within the ring, remember. And the CHO is attached to the ring. CHO group is attached to the ring. Here in this case now number 1 should be given to this ketone, remember. Number 1 is given to ketone. Then second position, then third position, then fourth, fifth, sixth. Okay, now first carbon is having what? Ketone, that is ONE, 1 O. Okay, and also this third carbon is bearing CHO group. In this case, for CHO, we should not say cyclohexane carbaldehyde in this case. Cyclohexane carbaldehyde should not be said. In this case, ketone group is there here, priority group is there because the carbon of ketone is forming the ring. So it should be taken as principal group and it should be what now? Only substituent. When it is substituent, when CHO is substituent, we have to use which name? Formyl. Formyl should be used for this CHO. So this formyl is attached to which carbon of this ring now? Third carbon. So 3 formyl, cyclohex. The ring contains 6 carbon atoms with all single bonds. Cyclohexane, hexane, ONE. ONE is what now? Secondary suffix. What is formyl here? Formyl is what here? Secondary prefix. Formyl is secondary prefix. ONE is secondary suffix. Remember. So like this, 3 formyl, cyclohexane, ONE is IUPAC name of this compound. Okay, let's take the screenshot of this now. Yeah, next. Yeah, now take it here. So in this compound here, this is special type here. This one we have to remember. So now in this example, what we have to understand is that this carbon is what now? Ketone carbon. Okay, ketone carbon. A C double bond O is there now? C double bond O carbon is forming the ring. That's why it is ONE. Secondary suffix is ON. Next, here in place of carbon atom of the ring, actually here this place what it should be? Here this carbon already has how many bonds? 1, 2 bonds already. This carbon has already 1, 2 bonds. So it should be what now? CH2. Here also this carbon has 2 bonds on both the sides now. So CH2. It is also CH2. But here in place of CH2, what is there now? NH is there. Means the carbon of this ring is replaced by what more? Nitrogen. The nitrogen atom is replacing the carbon atom here. The carbon atom of this ring is replaced by nitrogen. In this case, whenever nitrogen replaces the carbon of this ring, we have to use the name EZA. AZA, EZA. EZA should be used for this NH. So this NH is given name what now? EZA. Okay. And C double bond O is given what name? ONE. ONE. Secondary suffix name. EZA is what now? Secondary prefix. Secondary prefix name when NH group is forming the ring here. NH is within the ring. Is that clear, ma? So 2 EZA. Now first position anyhow ketone group na. Now nitrogen is given second position. The nitrogen atom also is given numbering now because the nitrogen is forming the ring now. That's why the nitrogen forming the ring should be given number 2 position. Lower number should be given to this. That's why first position anyhow to this principal group CO. Second carbon is the second position is to nitrogen. So this ESA group is at which position? Second position. So 2 ESA cyclopentane on. Cyclopentane on. Here why we are saying pentane? Actually it is derivative of what? 5 carbon ring only, no? From pentanone only we are getting this one. In that pentanone, one carbon is replaced by ESA group. That's why we are saying what now? 2 ESA cyclopentane on. Cyclopentane on. Though 4 carbon atoms are there here, we are using penta here because its parent compound is what? Cyclopentane on. The parent compound is what, ma? Cyclopentane on. That's why cyclopentanone should be used here. In this cyclopentanone, second position is having ESA group. 2 ESA cyclopentane on. Is the concept clear? Next. In this case now, check it here. Here also, here it is what now? Ketone. C double bond O ketone. For ketone, what should be given name? ONE on. Principal functional group it is. And for this NH bond is given what? ESA. ESA. And what is the CH3 group? Methyl. Methyl. So how many secondary prefixes? 2. ESA is there, methyl is there, secondary prefix names. And secondary suffix name is what? ONE on. And actually the ring is made up of what? 6 carbons. It made up of 6 carbons. In these 6 carbons, one carbon is replaced by what? ESA. When carbon is replaced by nitrogen or oxygen, this type of nomenclature is called what? Replacement nomenclature. Replacement nomenclature, because carbon is replaced by what? Nitrogen here. So we are giving special name ESA. Now, number 1 carbon is what now? This ketone. Carbon, first position. Second position, ESA. And third carbon is bearing what? Methyl. 3 methyl is there. 2 ESA is there here. 2 ESA, 3 methyl should be used. And first position, what is there? ONE on. Anyhow, first position is one ONE on only. So need not to say 1 on. 1 on need not to say. Simply we say directly ONE on. Because it is to be given what? First position only. Now tell me name. While writing again, ESA first letter is what? A. Methyl first letter is what? M. That's why first what we have to mention? ESA we have to mention. Where it is located, second position. So 2 ESA, 3 methyl, cyclohexane, ONE on. Cyclohexane on. Let's take the screenshot of these two more. Yeah, now next one's here. Next important word point what we have to remember is that cyclic esters. Generally, ester means what? Only ester means what? Bond COOR. It's called ester. Okay, so cyclic esters are called lactones. Lactones. Lactones are nothing but cyclic esters. This word you keep in mind. Cyclic esters are called lactones. The IUPAC name of these compounds are oxa. Oxa means in place of ESA, oxa we are using. Oxa cycloalkane on. ONE. Oxa cycloalkane on. Now in this case, check it here. Now this is ketone. C double bond O. C double bond O means ONE on should be there. Secondary suffix name is what? On. And here it should be given first position, ketone carbon, then second position to this oxygen, third carbon, fourth, fifth, sixth. Actually, this ring was made up of 6 carbons. In that 6 carbons, 1 carbon is replaced by oxygen here. Okay, actually 6 carbon ring it is. 6 carbon ring means we have to say hexa. Okay, so cyclohexane on. Cyclohexane on actually. Here at second position, what is there? NH or O? Bond O bond. It is oxa we have to say. Whenever carbon atom of the ring or carbon atom of the compound is replaced by oxygen, we have to use the word oxa. So 2 oxa we have to say. Previously for bond NH bond, what we used? ESA. For bond, NH bond, what we use it? ESA. And bond O bond in the ring is taken as what now? Oxa. So 2 oxa, cyclohexane one. Okay, and now in this case, check it here. It is C double bond O. C double bond. This carbon already has how many bonds around it? Already 4 bonds there here. See, this carbon has 2 bonds with oxygen, 1 bond with carbon, 1 bond with oxygen. Already 4 bonds there. No hydrogens will be there here. But here in this place here, this carbon has already 2 bonds. So it should be CH2 group. Here also CH2. Here CH2. Here oxygen is there. In place of CH2, what is there now? Oxygen is there. So in place of CH2 group, what is there? Oxygen. So oxygen replaced what? CH2. Is that clear, ma? So like this, what now? First carbon, this one. Now second carbon, second position should be given to oxygen here. Lowest number should be given. Lower possible number should be given. If you take anti-clockwise numbering, suppose first carbon, second carbon, third, fourth, fifth, 5 oxa we are getting. But 2 oxa and 5 oxa, which is preferable? 2 oxa. That's why we say what now? 2 oxa, cyclopentanone. Cyclopentanone. 2 oxa, cyclopentanone is IUPAC name of this compound. Is the concept clear about lactones here? What are lactones? The cyclic esters are called lactones. Only ester means bond COOR will be there. It is cyclic ester. Is the concept clear? So it's about what now we have the nomenclature of cyclic compounds. One more point what we have to understand is that suppose if you take this compound here, how many CH2 groups here? CH2 at every carbon CH2 is there here. So how many CH2 there here? Totally 6 CH2. So it is called here CH2 taken 6 times we can take now. So it is called hexamethylene. Hexamethylene. Here each methylene group is nothing but CH2 group. Bond CH2 group is called a methylene group here. How many methylene groups in this here? 6. That's why it's called hexamethylene. Hexamethylene or cyclohexane. Cyclohexane. So cyclohexane is called what? Hexamethylene. That's why cycloalkane